Okay, so this is a pretty cool little question. You can see the thing moves. It's beautiful. I don't know who designed it. The artwork, the action is beautiful. It shows. Back in my day, we just had static books that didn't move, didn't do any of this. I think this is beautiful. So this woman is traveling this way, as you can see, and as she does, her shadow gets longer and longer. You can see it in the action motion. So a street light is at the top of a 13-foot tall pole. So let's put that over here. So this pole is 13 foot tall. The woman is 6 foot tall. So there's the woman. She's 6 foot tall. She's a tall woman. 6 foot tall, walks away from the pole with a speed of 8 feet per second. So she's going that away at 8 feet per second. Okay. So gotta do a bunch of stuff here. So step number one, find the rate letters. So what rates do they talk about? Well, let's come up to the reading again. 13 feet, that's not a rate. That's just a height. 6 foot tall, that's just a height again. For the pole. Speed, there we go, 8 feet per second. That's a speed. Now, what is that? The speed up. Well, that's going to be if we call this X from here to the woman, call that X. How far, or whatever letter you want, how far the woman is from the pole. That is getting larger by 8 feet per second. It's increasing, right? It's getting bigger. X, the distance she is from the pole, is growing by 8 feet every second because she's going away from the light at 8 feet every second. There's that one. Okay. And then down here, they're saying, how fast is the tip of her shadow moving? Ah, so we got to bring her shadow into this. This is where it gets really interesting. So let's do, here's the tip of her shadow right there. Here's the tip. And so we're going to go from here to here. Call that Y. Wait, let me draw that. There's a tool. So Y, that's how long her shadow is, right? That's how long her shadow is. And so I'm going to say we need dy dt, but the answer, the final answer, it's going to get crazy there. The final answer will actually be dx dt plus dy dt. Why? Because as the woman, you can see it as the in the motion. Just watch the motion for a second. As the woman walks away from the light pole, what makes the tip of her shadow move on the ground? Two things. Basically, first off, how fast she's moving, how fast X is increasing, right? She drags her shadow, but then also her shadow gets wider on its own. So how fast this changes plus how fast that changes, dx dt plus dy dt is what makes the tip of her shadow move. We need both things. The growing of her distance from the lamp plus the growing of her shadow is how far all the way out to the tip of her a shadow, right? You could do, yeah, maybe I should show it that way. If I just go like this and I just go from here all the way to there, it, it's better. There you go. From there to there, that's what? X plus Y. That's how far to the tip of her shadow. It's X plus Y. So that's what they want to know the rate of change of. They want the ddt of X plus Y, which is dx dt plus dy dt, isn't it? That's that's what they want. What is that? That's how fast the tip of the shadow moves. That's what they want from us. It's, how far is the tip of the shadow from the light pole? It's x plus y. So how fast is that moving? It's the derivative with respect to time of x plus y, which is dx dt plus dy dt. That's why I say our final answer is going to be whatever dx dt plus dy dt is. We already know dx dt. We need to find dy dt. All right. That's important. Step two, find some kind of equation. This is an important step. Relating only those letters. No other letters. You can have numbers, but no other letters. That'd be just X and Y in this case, right? So we need some kind of equation relating only X and Y. Well, it's going to be similar triangles. Left is to bottom of the whole big triangle as left is to bottom of that. So similar triangles. Left is to bottom. So I'm going to go 13 is to X plus Y. As 6 is to Y. Do you see that? Left of the big triangle to bottom of the big triangle, X plus Y, is left of the little triangle to bottom of the little triangle. Those are similar triangles, left to bottom, left to bottom, left to bottom. They have to be in the same ratio. And so that means we can go diagonal, diagonal, and we get 13y equals 6 times x plus y. So there's my equation. 13y is 6 times x plus y, right? 13y is 6 times x plus y. So with that in mind, now we can clean this up a little bit, actually. 13y is 6x plus 6y, and now we can just subtract 6y from both sides. We can do a little work on this equation ahead of time. Boom, boom. And so we get what's that? 7y is 6x. There's a connection between y and x. Very nice. All right. Step 3. d dt. Both sides. So now I'm going to go, okay, it is time. d dt this side, d dt derivative with respect to time. So that's going to be 7 dy dt is 6 dx dt. Here we go. And then step 4, plug in the numbers. Plug in the numbers. Okay, do we know all these things? Let's see. Do we, well, I mean, do we have dx dt? Yeah, dx dt is 8. That's the only one we need. Dx dt is 8. So this is 6 times 8. And this is 7 dy dt. All right, let's divide on both sides by the 7. Boom, boom, because we're trying to find dy dt. Is 6 times 8, 48 over 7. Now that's dy dt. 48 over 7, but that's not our answer yet. Remember, as we analyzed up here, um, they're asked how fast is the tip of the shadow moving? Well, the shadow from how fast is the tip of the shadow? How fast is the tip of her shadow moving when she's 45 feet from the base pole? So from the base of the pole to the tip of her shadow, that is x plus y. The rate of change of that, d dt of x plus y, is dx dt plus dy dt. So the final answer is going to be dx dt plus dy dt. We already know dx dt is 8. So final answer, so we got this is 48 sevenths. Let's bring this up. 48 sevenths. So this is going to be 8 plus, and then we found out this is 48 sevenths. Now, you can hit the buttons on your calculator, and I'll go 8 plus 48 sevenths on Desmos. Let me show you, or you can do it by hand. 8 plus 48 sevenths, 8 plus 48 sevenths, like that. Then you can, watch, I'll hit this little fraction button there. Boom, it tells me 104 over 7. Either way, decimal, fraction, 104 over 7, whatever. 104 over 7, and that's beautiful. Here's our answer. So this is 104 over 7, or whatever the decimal is. That's how fast the tip of her shadow is moving. And notice we never used the 45 feet at all. Wasn't even needed. Interesting. There we go.